Hello, I'm Seema and welcome to part 3 of the chapter Chemical Bonding and Molecular Structure. In the previous part, I taught you how to draw the Lewis structures for different molecules. But remember, we are only imagining and allotting these structures to molecules based on our knowledge of their valence electrons and believing that they would want to acquire the octet. Every atom combines with the desire to acquire that magical number which is known as the octet, and that's the reason why all atoms they combine. But when we actually proceed to making the Lewis structures of molecules, we find that for some molecules it's possible to make more than one Lewis structure, and which seems to justify the molecule and seems to be justifying all the atoms. But yet, which one out of those Lewis structures should we choose? To know that, we have a process of calculating the formal charge of every atom in the molecule. And a Lewis structure which has minimum formal charges would be the one which would be the appropriate one, or would be the one that we would choose to be our final structure. So let us see what this formal charge is. According to your textbook, a formula is given for every atom for you to calculate its formal charge. The formula is that the total number of valence electrons in the atom, the formal charge is equal to the total number of valence electrons in the atom minus the total number of lone pair of electrons minus half of the total number of bond pairs of electrons. It's just a little confusing when you read the formula like this. Basically, what you're trying to find, what the formal charge is that whatever is the number of valence electrons in a neutral atom, you have to subtract from that the number of electrons that the atom has in the bonded form. Whatever it had when it was not bonded in the molecule, that number of valence electrons minus the number of valence electrons that it has in the bonded state. So that gives you the formal charge. It's very easy to calculate it. So let's see how do we do this. This is a molecule of ozone, and we want to find out the formal charges of all the 3 oxygens here. So let us say that this is oxygen 1, this is oxygen 2, and this is oxygen 3. So for oxygen 1, what would the formal charge be? There are 6 electrons in neutral oxygen, 6 electrons, okay? And 6 minus, how much does it have in this? You have 2, 4. See, if you follow the formula, how many lone pairs does it have? It has 2 lone pairs. So, which means how many lone pairs of electrons? So, in total number of lone pairs, there are 4 electrons which are present as lone pairs and 2 electrons which are present as bond pairs. So, we say this will be minus 4 minus half of bond pairs. Every bond is 2 electrons, and we assume that each atom is contributing 1 electron in that bond. So to this oxygen, only 1 electron of the bond belongs. Any single bond, any single covalent bond is made up of 2 electrons, and both the atoms, since they are contributing 1 electron each atom, 1 electron should belong to each atom. So we count only that electron. Since there are 2 bonds here, there should be 2 electrons belonging to this oxygen and 2 electrons belonging to this oxygen. So what would the number be? It would be 6 minus 4 minus 2, which makes it 6 minus 6, which is 0. But the way, the cheat formula is that the total number of valence electrons minus the total number of electrons it seems to have in the bonded state. So we say 1, 2, 3, 4 and 2 of these. So we'll say it will be 6 minus 6 is equal to 0. For the second oxygen, it has how many electrons now? Total number is 6, we know, minus 2, 3, 4, 5. It seems to have 5 electrons. So the second electron, 6 minus 5, should have a formal charge of plus 1. Right? This third oxygen, the third oxygen again has 6 valence electrons minus, it has 6 electrons we see here and the 7th electron of the bond pair. So it will be 6 minus 7, which is minus 1. So on the whole, plus 1 minus 1, on the whole the species should be neutral. So that's how we calculate the formal charges, and we try to see. Remember, the formal charge is not the actual place where the charge of the molecule is. When we write an ion, the entire ion seems to be having that negative charge, and we cannot specify where exactly is the electron which is responsible for that negative charge. Therefore, formal charges are only theoretical. They do not have any practical significance, but they help us to draw the Lewis structures logically. So let us now look at the second molecule. It's a carbonate ion. In this carbonate ion, let's try to find out the formal charges of all the species. Now this -2 is only telling us about the charge on the ion. So even when we find out the formal charges, our species should have the number of charges equal to this. The net charges should be equal to this. And if they are, it would give us an idea that the structure that we made is correct. So let's look at this. Carbon has 4 electrons. And 4 minus, how many electrons does it seem to have here? 4. So 4 minus 4 is 0. Carbon appears to have a formal charge of 0 in this compound. Now let's call this 1, 2 and 3, the 3 oxygens. So the first oxygen, oxygen 1 would be, what will be the formal charge? 6 minus 6 plus 1, 7. So 6 plus 1 minus 7 would be minus 1 charge. Oxygen 2 would have 6 minus 4 plus 2, 6. 6 is equal to 0. And oxygen 3 should have a charge of 6, 7. So 6 minus 7, which is equal to minus 1. So we see in the molecule there are 2 negative charges, and the net charge of the ion is also 2 negative. So this indicates that the Lewis structure that we drew is correct, or this is the appropriate Lewis structure for the carbonate ion. Let's take 2 more examples. Here we have HNO3, nitric acid. And let's see the formal charges of all the atoms here. Oxygen. Now there are 3 oxygens, 1 nitrogen. So let's start with the central atom. What's the formal charge on nitrogen? Nitrogen has 1, 2, 3, 4. It has 5 valence electrons. 5 minus 4 would be plus 1. Now 1, 2, 3, I'm moving in the same direction. This is oxygen 1, oxygen 2 and oxygen 3. Oxygen 1 should have a charge of 6 minus 4, 5, 6. So this is 0. Oxygen 2 should have O2, would have 6 electrons in the valence electrons, minus 4, 5, 6. 6 is equal to 0. And let us say here, this oxygen 3 has 6 minus 7. 6 minus 7, which is equal to minus 1. Right? And what about the hydrogen? Hydrogen has one electron, and it has 1 here. So 1 minus 1 is 0. So plus 1 and minus 1, on the whole, they get cancelled. These two, they get cancelled, and on the whole, nitric acid has a charge of 0. So this also shows that this Lewis structure for nitric acid is right. Let us now come to the last structure, sulfuric acid. And I've made this structure, and let's see if the formal charges are right for sulfuric acid. We know sulfuric acid is a neutral molecule, right? So what should be the formal charges? Let's look at the hydrogens. We see have a 0 charge here because they have 1 electron and they are terminally bound. They have only 1 electron and therefore they are zeros. And so we are now concerned with the sulfur and the oxygens. Now sulfur, like oxygen, has 6 electrons in its outermost shell, and in this structure it appears to have 4 bonds. So 6 minus 4 is plus 2. Sulfur appears to have a charge of plus 2 here. And let's see the 4 oxygens. I'm again moving in the clockwise direction, taking this to be oxygen 1. So oxygen 1 here should have 4 and 2. So 6 minus 6 is 0. Oxygen 2 should have 6 electrons originally minus 7. These are 6 plus 1, 7. So 7, which would be minus 1. Oxygen 3 would have 6 minus 6. 4 and 2 here. So 6 minus 6 is 0. And oxygen 4, just like oxygen 2, should have 6 minus 7, which is minus 1, sorry. Minus 1, right? Now, we find that plus 2 and minus 2, there are 2 negatives and 2 positives, which means that this should be a neutral molecule. So logically, this appears to be one of the structures that would be the right Lewis structure. But just see, if we, instead of having these oxygens here like this, if we moved a pair of electrons here and we move a pair of electrons here, let us now see what happens to H2SO4. Hydrogens, I told you, have charges of 0. Both the hydrogens, H1 and H2, have 1 minus 1, which is 0. So we are not concerned with that. So let us look. Would this structure be a better Lewis structure, or would the other one be? Now, in this second structure, we will now write with these two oxygens, that is oxygen 2 and oxygen 4 are different. So let us see what are the charges of oxygen 2 and oxygen 4. So let us start here. Again, O1, sulfur now has also changed. So sulfur in the final compound should have 6 minus 6. 6 minus 6 is 0. So according to this structure, the formal charge on sulfur should be 0. And the formal charge on oxygen 1 remains the same, that is 0, because we have not brought out any change in oxygen 1. The changes are in oxygen 2 and oxygen 4. Rest of the atoms remain the same. So oxygen 2, what charge does it have now? It has 6 minus 6. Do you see here? 6 minus 6. While oxygen 2 earlier had 6 minus 7. It had a charge of minus 1. But it now has 6 minus 6, a charge of 0. And third oxygen is again the same. There is no change. And the fourth oxygen here has how many? 6 again. 6 minus 6 is equal to 0. So we find that in the second structure, all the formal charges, or the formal charges of all the atoms, they come out to be 0. And the Lewis structure, which gives us the minimum formal charges, should be the one that we choose. Therefore, we decide on this structure instead of the one that I made previously. So that is how we draw formal charges, and that is how formal charges help us to draw the Lewis structures appropriately, or help us to choose the best Lewis structure. So this was about formal charges. Thank you for watching, and if this helped you, please give a like to the video, subscribe to my channel, and share it with as many friends as you can and recommend it to them. Bye-bye.